Okay, now let's look at the problem number 6. Have any students in the cluster number 2 have been expelled? Um, there are many ways. Actually, there are many ways. I mean, another thing is that this expulsion, right, is coded as either 0 or 1, right? And so actually, there's many ways you can solve this problem. The first way is if you look at the central table, the rate is 0.00831, right? So let's take a look at the centroid, right? And let's see, problem number 6, right? Cluster number 2, expulsion. Okay, cluster number 2, right? And expulsion rate is 0.00831, right? Okay, so so that's like 0.81%, right? Not 8%. So the answer is number of students in the class number 2, and then you can multiply by this rate, then you can get the answer. And another way is you can use the Python code. So I'm going to use a log, and then inside the log, I'm going to use the Boolean expression. The cluster number is 2, and this is AND, right? So this is AND. And then the student cluster expulsion is equal to 1, right? Then you can find a number of students, right, by executing this code. So there are two different ways you can solve this problem. And then problem number 7, on average, how many times have the students in cluster 0 been arrested? Okay, so cluster 0, right? So the average of the arrest variable for the cluster 0 is 0.907, right? So now cluster 0, right? The cluster 0 and the arrest is what? Rate is 0.906667, right? Okay. So please note that this arrest column, right? I mean, it could be any value. Okay, so this is not, is coded as 0 or 1, right? So the value, right, in the column arrest can be any integer value, right? It's not just 0 or 1, it could be any number, right? Because it indicates number of arrest. Any integer value, right? Such as 0, 1, 2, 3, and etc. Okay? And okay, then average, I mean, as you can see, the average value is what? 0.907, right? So please note that since this could be any number, when this does not mean that about 90% of the students in the cluster number 0 has been arrested. But that's not the case, right? That's a wrong interpretations. It means that what? On average, the students in the cluster number 0 has been arrested less than 1 time each. Okay, so on average. So that's what it really means. So please be careful. Okay, it's not that, it does not mean that 90% of the students in the cluster 0 has been arrested. That is very important to know. And then let's look at the problem number 8. The problem number 8 is, let's see. The problem number 8 is examining the centroid for the TOTIS, absence, and blah, 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 right? How many total students are there in the two middle risk clusters that would be classified as neither low risk nor the critical risk? So basically, you need to find the two middle risk, right? To answer these questions, you first need to find which cluster has the lowest risk and which cluster has the highest risk, right? In that, you can find the two middle risk clusters. So I want you to look at the centroid table and find out the lowest risk as well as the highest risk, right? Once you find both of them, then you can find the two middle risk clusters. So then you can find the answer. Okay, the problem number 9. Examining the centroid for the grade, which of the following would be most accurately describe this attribute's value in your K-means model, right? Okay. So let's take a look at the centroid table and then look at the grade, right? So this is the centroid table. And then when you look at the grade, look at the grade columns, right? Okay, and then you can answer the questions. Okay, you can answer the problem number 9. And then problem number 10, the question is build a model to create 3 clusters with a seed value of 7, random state being 0, and 10 max iterations. So basically, you change this value to 3, right? And then, yes, you can, after you run this code, right? Use this Python code, this single line of code, yes, you can answer the problem number 10. Okay, so thank you. I'm done with the exercise number 6. I mean, exercise 6.11. Okay, thank you.